So we're solving for two different things here, wavelength, and then we're going to be solving for energy in the next part, if you've looked ahead. This is the frequency right here. So this is what our nu is. It's the 95. Notice that it's in the wrong units. Sometimes I'll make a little note to myself just saying, hey, this needs to be changed to seconds to the -1. Now there's three equations that I could choose from for this one. C equals lambda times nu. There's energy equals H times nu, and then there's energy equals HC over lambda. Now the first question wants me to find wavelength. So I need to have a wavelength in the equation. So either this equation has wavelength, you can see, or this equation has wavelength. So it's going to be one of those two equations I'm going to need for this part of this problem. And so I need to look at what I have. And if I go over here, this is what I have is frequency. It's this nu. So I need to pick between the two of these, I need to pick the one that has a nu in it. And it's this one. There's not a nu in the other one. So I'm not using those equations. I'm just using this one right here. So what we're going to do is make sure we are solving for what we want to solve for. This is what we want to solve for. It's asking what is the wavelength. We want it by itself. So we're going to divide both sides by the nu. C over lambda equals, C over wavelength equals lambda. And if you prefer having the letter on the left and you want to rewrite it like that and erase this one, it's fine too. I'm just going to keep it as it is though. And then, so I just remembered I need to change this before I plug anything into that equation. So the way I change it is by saying 95 millihertz. Go back to stuff from chapter 1, milli into just a hertz. And so there's 1, it goes with the prefix, and 1 times 10 to the -3, because that's the base unit right there, a hertz is. And if you want to go ahead and put in the conversion between hertz and 1 over seconds, or seconds to the -1, you can. It's just 1 to 1. But that way you can see that this unit cancels and then that this unit cancels. So my number I'm going to be plugging in is 95 times 1 e to the -3. So that gives me that my frequency that I'm going to be plugging in is 0.095, and it's seconds to the -1 or 1 over seconds, however you want to keep that. So that's what I'm plugging in there. And I know C because C is the constant for light, 3.00 times 10 to the 8th meters per second divided by 0.095 per second. So this gives me 3, and then E to the, I can do 3.00 also, divided by, and I've already got that frequency in there, so I'm just going to use the second key on my calculator to get the number. So that gives me 3.2. Remember sig figs, 1, 2 sig figs. Those zeros on the left do not count for sig figs. And usually we don't include constants for sig figs either. But just as a note, it wouldn't matter anyways because it has 3. So 3.2 times 10 to the, and I'm going to have to count it by hand. 1, 2, 3, 4, 5, 6, 7, 8, 9 is what I count. And then the units on this, it's a meter times a meter, divided by seconds, divided by 1 over second. Remember, the math on that gives us a meter over a second times, and you have to invert that. So those cancel, and that gives you the unit being a meter, which is great and makes sense because this is a length, a wavelength. So the unit needs to be a meter.